Have you ever wondered why the derivative of exponential x is always equals to exponential x? Here is the reason why it is so. Now let's look into that. You are going to be proving this, so this is like a proof. So want to prove this, okay? So the proof now, I get what I'm saying. So want to prove, and then our proof is not going to be what? Our proof is going to be that, so we are going to be using the limit rule. So the limits, we know that the derivative of a function, is equal to what? Limit as h approaches 0 of f of x plus h minus f of x divided by what? By h. We should all know this rule, okay? So now what does that tell us? So if you are applying this is going to give us limit as h approaches 0 of what? Exponential x plus h, right, minus exponential x divided by what? By h. You may be wondering, how did I get exponential x plus h? What I did is, your f of x is already given as, exponential x, so your f of x plus h will just be what? Exponential x plus h. So that's how I got that, okay? Then the next one there is, I will apply exponential rule. So I'm gonna have limit as h approaches what? 0 of exponential x multiplied by exponential h minus exponential x, okay? Then divide by what? By h, and that's gonna give limit as h approaches what? As h approaches 0 of exponential x is a common factor there, okay? Exponential x is a common factor, so we have exponential h minus 1, then divide by what? By h, and that would give, now we apply the rule of limits. That's it. I can bring the constant to the front here, so I'm gonna have exponential x, then limit as h approaches what? As h approaches 0 of exponential h minus 1 divide by what? By h. So now this is where we are not going to apply a rule. We are going to apply the Taylor series expansion. So we are going to be using Taylor series expansion. You should know this also. The Taylor series expansion for exponential h. The rule is what? Exponential h, the Taylor series expansion of exponential h is going to give you 1 plus h squared over 2 factorial, plus h cube over 3 factorial plus dot, okay? That is the rule. So we are going to substitute that into this, and then that would give us f prime, don't forget f prime of x will now be equal to what? Exponential x, then what? The limit as h approaches what? 0 of, so rather than writing exponential x now, I'll put all these value, okay? So we have 1 plus h squared over 2 factorial plus h cube over 3 factorial minus 1. I just want to stop there, minus 1. So you can see clearly here, 1 is going to take on negative 1. Don't forget divided by what? By h there, okay? And then from there you're going to have exponential what? X limit as h approaches what? Limit as h approaches 0 of what? H plus h squared over 2 factorial plus h cube over 3 factorial, okay? Then divided by what? By h, and then we can factor out h there. So we have exponential x, the limit as h approaches what? As h approaches 0, okay? So we can factor out h there. so that we are going to have h, then we'll be having 1 plus h over 2 factorial, 1 over 2 factorial plus h squared over what, 3 factorial. Okay, then divide by what, by h, divide by h, and then h will take on what, on h, and then we'll be left with what, exponential x limit as h approaches what, 0 of 1 plus h squared over what, over 2 factorial plus h cube over 3 factorial plus dot dot dot. Then that will leave you with what, exponential x. You can still apply the limit. You know this is a proof, so I'm just proving, and so you can apply the rule also, and then you're gonna have exponential, the limits of a constant. The limit of a constant 1 is gonna give you the constant, so this is 1, and if you apply the limit to other value, you are gonna get plus 0, so this is plus 0, okay, plus 0, and that will give you what, exponential what, x, because exponential x times 1 is exponential x, and that is f prime of x equals to what, exponential x. So this is the reason why we say that the derivative of what, exponential x is equals to what, exponential x. So using the same thing, the same method, I'm sure you can try this. So using the same method, you can try this. The reason why exponential kx is equal to k exponential kx. So drop in the comment section if you were able to try this, or if you love me to try it, you can drop your thoughts in the comment section. Thank you very much for watching. Don't forget to subscribe, like, and share this video. All right, thank you very much. I remain myself, Colossus, and I'll see you on the next one. Bye.